So welcome back, everyone, and hope you had a nice weekend, and congrats on finishing assignment 2. Some of you got in touch with me to report problems with the auto-grader feedback you received, and I am still working on sorting that out. So in the meantime, I apologize for causing undue stress or confusion, and I will correct that soon. Okay. Also, to refresh your memory, on Friday, we had gone over dictionary and set comprehensions and generators and iterators. And then today, we're going to be attempting to finish off the Module 2 material by talking about some of the nitty-gritties of how Python carries out computations. But before we get into that, does anyone have any questions or comments about any of the material or assignments so far that you'd like to bring up first? Okay, nothing. Okay, so understanding how Python or any computer language for that matter does its computations is fundamentally about understanding which values are operated on, and then which operators are applied, and then when those computations are actually carried out by the CPU. So in Python, that means understanding variables, or like things that will be computed with or on, and operators and functions, or the things controlling which computations will happen. And then like control flow concepts that govern when different computations will happen. So you've got like what's being computed, how is it being computed, and when is it being computed. So way back at the start of this course, we talked about some control flow constructs like if statements and loops. And then on Friday, we went over generators and iterators, which right. And then we talked about the distinction between so-called eager evaluation, where computations are carried out immediately, although I don't think I actually introduced that word, but that's what it's called, versus lazy evaluation, where computations are carried out only at the last possible moment when a particular value is needed. So at this point, we have almost all of the pieces in place, but the last big set of concepts you need to know about Python is about how variables are treated. So in other words, like when you want to get out the value of a particular variable, it's worth understanding a bit more about how that's done. So to get started thinking about this, first of all, I'll share my screen. Okay, and then let me restart my runtime. Okay, and make you bigger so that I can see you. Okay, great. Mostly great. Sorry, one sec. Too many windows here. Okay. Okay, so let's take an example function and try to logic through what value will be returned. Okay. So I'll make a variable x and set its value to 1. And then I'll define a function, foo of x, which returns whatever you pass it, or it returns x. So if I were to call like print foo of 2, what's going to get printed? So I define x to be 1 here, but then I've passed in a 2 here. So like, you know, likely candidates might be 1 or 2. But what do you think is going to happen?
It's going to return 2.
Yeah, it's going to print out 2. Yeah, so we can verify that. Oh, first it has to connect. Okay, great. Okay, so how about this one? Let's make it a little trickier. How about that?
It's going to return 3. Or print 3.
Yeah. Well, both, I guess. Yeah, this function will return 3, and then this statement will print 3. Yeah, so anyone who followed that, can you explain like why we got those answers? Like how did you know, or how does Python know which version of X to use? What do you think?
Jeremy, could you print just X for us?
Yeah, X is 1. Confusing, right? Maybe. Or is it? Oh, I got a yes. Mary, does that mean you want to take a stab at answering, or yes, it's confusing, or yes?
Yes, it's confusing.
Yes, it's confusing. Well, great. And it's a good example. Well, some of you answered correctly. So how did you just guess? How did you think that through?
They're just different like scopes. So within the function is a different scope from outside of it. Where outside the function X is 1. And inside, that's not necessarily true.
Yeah, but so what do you mean by scope? We haven't learned that word yet.
Yeah, I'm not too familiar. I mean, like, I guess just the tab is kind of, or like the inset is kind of the scope.
Okay. Yeah. So as Brian said, yeah. So let's just dig into it. Yeah. So when we reason through this stuff, what we're really thinking about is this concept called variable scope, and that refers to which variables are known to or accessible to the interpreter at a given moment during a program's execution. So when you first start a Python session, actually, let me restart my runtime so we don't get confused. So when you first start a Python session, the list of variables available to you, or like, in other words, that Python knows about, can be captured using the dir command. So that's what it looks like. That's what Python knows about. And then, so that's kind of a interesting list. Like some of these might not make sense. And then if you want to know like what these variables are, the locals command returns a dictionary that also contains the values of those parameters. And then you can like store that dictionary or the output of locals into a variable. So let's put it in the variable X. And then we can show that it acts like any other Python dictionary. So type of X is a dictionary. And then if we wanted to know the value of the quit command, well, that's some weird type of special Python object. It's actually an instance of a class. or like built in. What is that? It's a module. Can anyone think of what might be in the built-in module? It's like what makes Python Python. All the things that are in the Python language that are built into it. Yeah, kind of weird. Okay, and then so when you define a new variable, it gets added to this dictionary as a new key, and then it's visible when you call locals again. So let's assign a new output of locals to another variable y. Okay. And then if we like look at the which variables are known, this little x here is hiding out because we just defined or assigned a value to the variable x, so that didn't exist when we first started Python, but now it does. And then you can also like check whether a dictionary or any dictionary, including locals, contains a particular key by using the in keyword, like x in y.keys. And notice there's a difference between like x in quotes versus like x, which is a dictionary. This will not be, oh, it's not even, can't even run. Does that make sense? So this is useful also if you have like x in the list, x, y, z, that will return true. Okay. Okay. So far we've learned that when we create a variable in the main Python workspace, which is what we're working in here, that variable now becomes available for us to reference and call. Okay. So then let's see what happens inside of a function. Okay. So let's write, you know what? I'll factory reset the runtime again. Why not? Okay. Okay. Okay, so we'll, so x1.locals now, what's that gonna have in it? Like all the variables we've made so far, which in this case are just A and B. Okay. Okay. Now let's write a function, foo A, that returns new locals. Oops, that's not gonna run. That will. Okay, we'll say x2 equals foo of 3. Okay. So x1 contains all this stuff, like all the variables in our workspace. But x2 just contains whatever we passed into this function. Okay. So first of all, does that make sense? All right, is anyone like, I'm seeing like shifty eyes here. Does that signal confusion? Am I reading that correctly?
You lost me a little with that last. You lost me a little with that last function, returning locals. I don't know what that means.
Okay, great. Okay, so let me try again. The locals command returns a dictionary containing the names and values of all of the variables that Python knows about at that point in the code's execution. So if you call it in the main Python workspace, the locals variable knows about everything because it's like the highest level thing. But inside of a function, the only thing the locals that Python officially knows about is the stuff that you pass into the function. In this case, just one variable, which we called a here. And so it's also like, does that make sense? Okay. And then we could also say, like, what's the value of a in the x1 locals? Because remember, we set a to 1 and b to 2. And so the x1 version of like what everything means, like the universe, we can get at by x1 of a, because remember, x1 is like a dictionary, like everything else, or like any other dictionary. Not everything is a dictionary. And then x2 of a is a different thing. That's the version of a that we passed into this foo function. Okay. But now, and then like x1, we could also ask what b is, and what's b going to be?
Two.
2. Wonderful. And then what about x2 of b? What's going to happen there? Is this valid? Can I run this?
Error.
Error, yeah, because there's no key b. So the locals that are local to the foo function it doesn't contain the variable b. Okay. But there is a nuance, which is that any variable that's defined inside the body of a function takes precedence inside that function. So if we were to do something with a inside this function, then this value of a would be used. But anything that's not defined in this function that we reference in this function, so like anything in the main workspace or in the body of a statement that the function definition is nested in, may also be referenced inside of that function. So like this, this is going to work just fine. Let's print out the value of b. Oops. Okay. Okay. Yeah. Oh gosh. What did I do here? Is it? Oh, there we go. Yeah, that was a single quote, double quote thing. Here's how I could have done it. There we go. That should work. Okay. I guess I should point out that error. So I have a single quoted string here. So if I include a single quote as part of that string, Python will think I've now ended the string. And so if I put like 2 next to each other, then that is really equivalent to something like that. So it's not actually like continuing. Anyways, and then the second string here is not a F string anymore. And so the enclosing a value in curly braces doesn't work anymore. So a proper way to include a single quote inside a single quote string is either to use this \, which is called an escape character, or the other way to do it is to turn it into a double quoted string, and then single quotes are just fine. Okay, that's an aside there. Okay. Yeah, so again, x2 doesn't contain b, but I can still refer to b in this function because it was defined like kind of outside of the body of this function in the enclosing scope, if you will. Okay, so if you want to explore Python scope further, then I'd recommend also checking out the globals function and the theirs function. Those are both useful. But the key idea that I'd like you to take away about Python scope for the purposes of this class are that when you can access a variable and what variable or what values a variable will take on. And so the kind of summary is that you can access a variable if it's been defined previously in the main Python workspace, or if it's contained in the body of some statement that encloses wherever you're referencing that variable from, or if a variable is defined previously within the same body of whatever statement you're running, then it can also be referenced. And then the body of a statement or definition is where its scope is defined. Like that's what its scope is. And then the value that a variable takes on is determined by whatever the most local statement body is that defines that variable. So if you assign a variable within a function, even if that same variable name appears outside of the function in an enclosing statement, the version of the variable named inside of the function will take precedence. Okay. That can be tricky to think about. Any questions about variable scope? Weird situations you want to explore? Points of confusion there. Okay. Well, keep thinking about that. Another important concept that complements the notion of scope has to do with how Python actually returns the values of its variables. So to understand that on a deeper level, we're going to need to dig a bit more into how Python is actually working behind the scenes or like under the hood to control the computations that our computers carry out in response to the code we write. So if we take a let me actually clean this up. Okay. So let's take a simple example, like assigning the value 3 to a variable x. Okay. So we all know, like, what's the value of x now? It's not a trick.
3.
3. Yes. Okay. Yes. It's not a trick. Yeah, Python still works like Python. So there's no new twists here. Okay. So what happens internally when we run this is that the computer stores the value 3 in some memory buffer, and then the variable name x in some other memory buffer. And then Python makes a little note called a pointer that tells the interpreter that whenever you reference the value of x, we should look up the place in memory where he had stored the value 3. So it's like an arrow drawn from the name x to the location in memory storing the value 3. Okay. Does that make sense? A buffer is like a place, it's like a bucket for storing things, like a number. Okay. And then, so let's assign a new value to x, like 4. Okay, so now x is going to have the value 4. That's not surprising. But what happened when we did that is that the value 4 is now placed into a new buffer. And then x's pointer is updated to point to that new buffer's location. Okay. So if we can evaluate x, and it used to be 3, but now it's 4. But secretly, the 3 is still hanging around somewhere in memory, but it's kind of just sitting there with nothing referencing it. And if it hangs around too long with nothing referencing it, Python will periodically execute a process called garbage collection, which clears out any unreferenced memory buffers. And if you want to, you can actually force that process to happen at a particular point using the garbage collection library called GC for garbage collection. And here's how you collect the garbage. Much easier than in real life. Okay, there we go. We've collected the garbage. So if we had collected some huge chunk of data and like assigned it to the variable X, and then reassigned the value of X to some new block of data, then forcing garbage collection would free up that memory for other processes to use. And that could make your computer run faster or more efficiently. Or if you've used or will use a computing cluster or other resource constrained system, then exerting finer control over garbage collection can sometimes be a really useful and effective way to reduce your memory usage. Okay. There we go. Okay, so let's assign a new variable, y, to take on the same value as x. Okay, so what's y going to be now? Again, not a trick. What do you think it's going to be?
4.
Yeah, great. Okay. But then what happens if we update x again? Okay, so let's make x 5. Does y now point to the same place in memory that x used to point to? Or does it keep tracking with x no matter what we've updated x to, or like when we update it? Like if I run this line, what's going to be printed out? Is it going to be 4 or 5? Or, let's see. Yeah. So why did you think 4?
Because the pointer for y wasn't updated to the new location.
Exactly. Yeah. So as Mary, I think it was you talking. I didn't get your, just a disembodied voice there. Okay, yes, I'm getting a yes. Okay. So what's actually happening, as Mary noted, when Python evaluates the statement y equals x here, is that the variable x, or sorry, I'm going to try not to mess up x and y because that would make things very confusing. Okay, when I run y equals x, what's actually happening is that the variable y is assigned a pointer that points to whatever location x is currently pointing to. So in this case, x was pointing to a buffer containing the value 4 at the time we evaluated this statement here. And so now y points to that same buffer. But when we tell Python to update x by calling this line here, all Python does is it updates x's pointer to go to a new location in memory, which is going to be stored in a new buffer. But nothing else has changed unless we explicitly instruct Python to change it. And since we didn't tell Python to do anything with y's pointer, it remains unchanged and continues to point to that same location in memory that it was pointing to before, which contained the value 4. Okay.
So, Jeremy, is there a way
Yes.
to program it so that y would keep track of x whenever we change x? Like a simple way?
Do you know that line in Star Wars where it's like Anakin Skywalker asks Palpatine, like, can I learn this? And Palpatine's like, not from a Jedi. Well,
okay, yeah.
Not that. It's it's not under the standard operating rules of Python. Yeah, so it has to do with something called passing by value versus reference, which I want to like go through more formally, but I'll get to answer your question. Okay. baby steps here. Okay, so let's do a let's make another function to dig into this even more. Okay. Okay. So what this does is we've defined a function where you pass in something, and then it takes that something and assigns it to have a value 2. Okay. So if I call like, and remember, x is given a value 1. So what would happen if I did this? Like, what is the value of x now? Like, how could we reason through that?
Well, it would be assigning the local variable that you passed to it as 2. So the global variable is not going to change.
Yeah. Okay. Yeah, that's tricky to follow, but yes, that's correct. Okay, so to walk through this in like excruciating detail, but it can be instructive to do that. So we first assigned, in this line, we assigned x to point to a buffer containing the value 1. Okay, like always. Then we assigned a new variable, myfunc, to point to a buffer containing this function definition. Okay. And then in this line, we called myfunc with the variable x as its argument, which just passes its pointer into myfunc. And then once this line executes, what's secretly happening, or not really secretly, what is happening is the Python interpreter next goes to this line inside the body of myfunc. And now whatever we passed in is now called y. So when we enter myfunc, y points to the same location in memory that x did. But when we execute the first line, which has a value of 1, but when we execute the first line of myfunc, the variable y is updated to point to a new location in memory that contains the value 2. And then the function returns or exits, and it returns none since we didn't specify a return statement. But now if we refer to x outside of myfunc, since the x in the main workspace still goes with the original pointer to the location containing the value 1, x isn't changed. Okay. So does that make sense? Okay.
I think, sorry,
Oh,
quick question.
yeah.
And sorry if you've like already gone over this, but like, if it was like, if you were defining the function of x though, rather than y, because right, it's changing x into y when you put it through the function, but if you were changing the variable assigned to x in the local, like the local variable, would that change it overall or not when you went outside of the function?
So that's a great question. Well, I guess there are 2 possibilities for interpreting your question. Did you mean like if I change this to an x and this to an x?
Right, yeah.
Okay, so let's try that first. Okay, so x is 1 out here. I run myfunc of x, and then, I don't know, what do people think is going to be printed out here? It's 1 or 2? Okay, lots of 1s. Yeah, okay. So Python doesn't care what you call variables. It's just like inside this function, whatever gets passed in, which could have a name of x, it could have a name of y, it doesn't matter. We're just going to refer to it as x inside this function. Okay. Okay. The other possible interpretation of your question, which is was Like, what if I call whatever I pass in y, but then I refer to x here, which we know from talking about variable scope will actually refer to this global variable here. Okay. Now what's going to happen? So what's x?
Three.
1. It's either 1 or 3. Still 1. Yeah, confusing. Okay. Yeah, so
You can change it as when you return x in the function.
oh, yeah, we could return x, and we could say x equals this. That would certainly change its value. Okay, so to understand what's happening, we can print out some like debugging statements. Okay, so let's see. Yep, let's just print out the values of x and y. Let's see. Sorry, these aren't actually lines, but whatever. I could say statement. There we go. Okay. Okay. Oh. Okay. Okay. This is actually an interesting thing. So the variable x is defined outside of the scope of the function. And so when you define x inside of a function, but also like it forces the scope of the variable named x to be local, because you can't have two things called the same name. And so this line actually kind of contaminates the rest of the function so that you can't refer to the global version of x. Well, not if you there's a trick to do it, but without using that trick. There's a keyword called global, which forces things to be global. It's bad practice to use it, so I'm not even going to teach it to you. Okay. Yeah, it's like import star. You don't do that. Okay. Okay, but if I remove this line, then things will work. Okay, I think. Okay, wonderful.
So
yeah. Sorry, Chris, is that you talking? Okay.
Yeah, sorry. So does Python sort of like read ahead there? Because that line was ahead of x being assigned. So even if it was like the last line in the function, would it still sort of like know that?
Yeah, I mean, we can try that, right? Yep, last line. And yeah, confusing thing is here. So we're not assigning x to anything. So that's totally fine, because you can compute with x just fine. But if you assign, like if you name a new variable x, then the act of doing, like if you use the assignment operator and the result is to create a new thing named x within the local scope, even if it's later on in the program, Python has like looked ahead and realized that anything called x here, we're referring to the local version. So it'll complain if you refer to the like global version before you've defined the local version, because it knows that I'm only going to look locally for this thing. Okay. Yeah, so that's another kind of glimpse into what Python is doing behind the scenes. We think of Python as executing our code from top to bottom, but I mean, it's not usually necessary to understand it at this level, but like your CPU, which is the thing that's actually running the code, or in this case, like Google Cloud CPUs, which is actually running the code, doesn't understand Python. It understands machine code, which, like, you know, zeros and ones, or like assembly language, that sort of doesn't matter. If you haven't heard of those, they're just instructions. It's like your calculator understands like addition and subtraction, and your CPU is like a fancy version of that. So what's happening when you run code is it's getting translated into a language that the machine understands. And part of that process does involve reading ahead. Python is what's called an interpretive language, which means it kind of runs mostly in sequence, but for when you have a statement body, it has to know the complete body of that statement. And like, it kind of treats this almost as like one line. If it's not, it doesn't really treat it as one line because white space is meaningful in Python, but you can think of it as kind of one line of code from the perspective of the like compiler and processor. Okay. Yeah, so so this example kind of makes it clear that even like, you know, when X is defined outside of the scope of the function, it doesn't get changed, even though X and Y initially point to the same location in memory. Okay, so it's the same logic again. So thinking about these simple or simpler-ish examples can help you to logic through more complicated examples. And the key is, again, to understand like when the pointer that's linked to a variable gets changed. Okay. So now let's do a trickier example with dictionaries. Okay. Okay, so let's make a simple dictionary. And then we'll oops, I didn't want to do that. Return Y. Okay, and then Z equals. Okay. Oh gosh, just kidding. That's why you factory reset your runtime if you're smart. Okay. So let's see what X is. So X is this dictionary that we defined to have, oh geez, I gave away the punchline. It started as a dictionary with a 1 for A and a 2 for B. Okay. Well, I guess I won't ask you what you'll get. Before you run that line, A is 1 and B is 2. Okay. And then I run this line passing in X, and you might like think naively that it's going to act just like the other example where you pass in like why is a dictionary different from like the number 2? It seems like they're all kind of, you know, in some sense they're all objects. Like, why are they different? Okay. But here's what's happening. So the way that, so the variable X here is associated with a set of locations in memory that comprise a dictionary with keys A and B. And then the way that dictionaries are stored is that X points to a list of pointers, like with 1 pointer per key. And each key's pointer points to a buffer with that key's value. So when we pass X to my func here, the dictionary's pointer is what gets sent to the function. And then within the scope of the function's body, that pointer is called Y. And then inside the function, we update the A key of the dictionary that of that dictionary to point to a new location in memory. And so the original buffer that contained a value 1 doesn't get changed. All that gets changed is that the list of pointers that the dictionary variable like points to is now updated so that the A key's pointer now goes to a new location in memory that stores the value 2. So in other words, like the original X of A contained a pointer to a buffer that stored the value 1, but inside my func, the location in memory that stores X of A's pointer is getting updated to a new pointer that goes to a buffer that stores the value 2. So nothing else got changed. But that means that any variable that points to the same buffer containing a list of pointers, like for this dictionary, will get affected by like anything downstream of it. So Z and X both get affected when we update one of the dictionary keys inside of my func. Okay. That makes sense. Tricky. Okay. So it's like, what is Python thinking of when we say X here? It's talking about a list of pointers, which are, it's like a map that's going to tell us how to find A and B. But if we, and so the map, whether we call it X or Y, is going to go to the same place. I mean, you know, we could set Y here to some other dictionary. And now X won't be changed. But if we update that map, then now the map is changed, and that's just sitting there. That's like the thing that exists in the universe. And then when we refer to X later, all Python knows is how to look up that map, which in turn gets you to other places. So if the map itself changed, it'll get to the same map, but now the map looks different, and so X is different. All right. So, okay, any questions on that? Okay. So in general, these examples relate to a concept in computer science that I think it was Mary referred to, called passing by reference. So it refers to how you communicate the value of a variable to a function that you're calling. And what passing by reference means is that when you call a function using a variable as an argument, what you actually pass to that function is a pointer to the location in memory that stores like whatever valuable that variable is associated with. And then if you change the contents of that buffer or anything referenced by that buffer, like pointers to other buffers, then the value of the original variable will change. And every time you pass a variable to a function in Python, it passes by reference. Okay, so that's thing one. The other way that you can call functions is passing by value. By other way, I mean in the general sense, not in Python. Okay, so that means that instead, like you could imagine in a different language, that instead of sending a pointer into like whatever function you're calling, you could instead like copy the value and then send that value stored in some location in memory to that function. Okay, so like effectively you'd be making a copy and then manipulating the copy instead of the real thing. There actually is a way. Now that I said there's not a way, I remembered there is a way to actually make copies of things. It's called the copy library. Weirdly, it's the copy function from within the copy library. So here's how I usually call it. But if I run this line and then say my func of copy of X, then X will not be changed. Okay, so what this copy function is doing is it forces like pass by value instead of pass by reference. Okay. Okay, but Python doesn't, this is like literally you are manually making a copy of something and storing it somewhere else in memory and passing that other thing to the function you're calling. So Python is still passing by reference, it's just to a different thing than X here. Okay. So in practice, thinking about how fields and variables are updated in Python can sometimes be confusing. And rather than attempting to memorize a set of rules about how variables are treated, I'd recommend just letting the explanations of how Python treats variables kind of wash over you. And now that you've heard about it once, and like that's going to probably be sufficient for most of you. And as a shortcut, now that you know that Python can sometimes be weird when it changes the values of variables or fields versus just updating a pointer, you can like add it to your mental list of things to consider when your code is acting strangely. And a perfectly legit way to work through these issues is to print out the values of different variables or fields at different points in your program and like verify using those print statements that things are changing or getting updated in the ways you expect. Okay. All right. Any questions about that? Some tricky stuff.
Would it do the same thing for like a list, or is it just dictionary specific?
Yeah, let's try. So let's see. So let's make a list like 1, 2, 3, 4, 5. And let's say we're going to replace the third element, so like index 2, with a 10. Okay. This is like what you're asking about? Okay. So first of all, X, just to verify, is the list we assigned. But if you call my func of X, what happens? Okay, so Z behaves like we expect. And X is also changed. Okay, so that's working, like actually coding it up is the best way in practice to verify rather than attempting to memorize. Lists, like dictionaries, internally are also like secretly pointers to sequences of things. So like a list in Python is like, it's like a link to the, well, it's a link to a link to the first item in the list. And then each item is like that item plus a direction to get to the next item. And when you replace an element, so if you learn about, like you'll learn about something called linked lists in module 3, and like under the hood, this is how Python treats regular lists. It's just that we don't have to specifically care about how it works. Yeah, so Python tells you how to get to, well, you can think of it as getting to the first open square bracket. So it's totally fine. Also, like it'll also work if you change the first element in the list. It'll like mess everything else up. And then the first square bracket you can think of as pointing to the first item, and then each item gives you the next item until you get to the last item, which points to like, you can think of it like pointing to the end square bracket. Okay. So that gets us to the end of module 2. And so now that we are here, you've essentially gotten all of the major plot points in Python. So you really know the language now, and it's kind of just a matter of practicing it and like getting used to how it works. So congrats. And hopefully you've learned something so far, even if you came in already with some Python experience. On Wednesday, we're going to start module 3. And in module 3, you'll get a little taste of some of the more classic computer science concepts like sorting and some basic data structures. just so you have a little exposure to those ideas in case they come in handy in your research. And then up to and including today in our synchronous meetings, I've really been like reviewing the material that you learned on your own in the tutorials. Because like for one, it rarely hurts to see things twice. And then second, it's really important that we're all on the same page, or mostly on the same page, about like how to write and think about Python. But moving forward, starting on Wednesday in module 3, I'm going to be changing the focus of our synchronous meetings away from repeating the material from the tutorials. And instead, we're going to like emphasize the key concepts by working on examples together as a class and also in smaller groups. Okay, so to that end, if you haven't already done so, please start going through the module 3 material. And then I'll, again, I think in every class, leave time at the beginning for anyone to raise questions or like points of confusion. And then, you know, we'll go through those, and then we'll kind of work on different exercises to help kind of drive home the concepts with our main class time. And then to give you a sense of pace to help you plan, I'm hoping that we can get through the module 3 material in about a week. And that's going to let us kind of close off the more purely computer science, like learning to code stuff. And then we can get to the psychology specific stuff that I think you're going to have fun with, possibly more fun with. We'll see. All right. So see you in class on Wednesday.